Good day everyone! Today we'll be doing laboratory for Arduino's basic input and output. And our objectives include familiarizing ourselves with Arduino Uno hardware, Arduino software version 1.5 or newer, and writing, compiling, downloading, and testing programs to control LEDs using digital outputs on the Arduino Uno. So the materials that we'll be needing include breadboard with Arduino Uno, adapter, 120 volts AC to 12 volts DC, a digital multimeter, 220 ohms resistor, and LEDs. So without further ado, let's proceed with our first two circuits. As you can see in the screen, we have the circuit 1 and the circuit 2. So we'll first do the circuit 1. So this circuit diagram involves Arduino Uno, a 220 ohm resistor, and an LED connected to the ground. So our task for this program 1A is to write a program to blink an LED on pin N as shown in circuit. So the LED should blink 1 time per second, 0.5 seconds on and 0.5 seconds off indefinitely, which means it will just go forever until we stop the simulation. So we will also need to do or to create or to draw an schematic diagram using whatever software that we want, and for my case, I'll be using Tinkercad. So let's proceed to our Tinkercad. So as you can see, we've already placed the components. We have the Arduino Uno board, the breadboard, as well as the resistor and the LED. And this is the corresponding code that we'll be using to simulate the program that we want, which is the program 1A, or the objectives that we wanna do. So we have the int LED8. This line declares the integer variable LED and initializes it with the value 8. It represents the pin number, as you can see in the screen, to which the LED is connected. We also have the void setup. This function in Arduino sketches runs once when the Arduino is powered on or reset. It is used for initializing variables, pin modes, etc. As you can see, we've mentioned the pin mode, so we're using the pin mode LED output. Inside the setup function, this line configures the pin specified by the variable LED, which is in the pin 8, as an output pin. This tells the Arduino that we will be sending signals to this pin to control an external device, which in this case is the LED. We also have the void loop. So this function in Arduino sketches that runs repeatedly after the setup function has been completed. It contains the main code logic, which is this one, our main code for the program blinking LED. So we have the digital write LED high. So this line sets the pin specified by the variable LED pin 8 to a high voltage level, turning the LED connected to it on. So that's what it does. And we have the delay 500, which is 0.5 seconds delay. So as you can see, we have the 500. This is because we are using milliseconds for the delay. So in this case, it causes a delay of 500 milliseconds, or when converted to seconds, 0.5 seconds. We also have the digital write LED low, which is low voltage, turning the LED connected to it off, and another 500 milliseconds delay for the off, which creates a total of cycle time of 1 second, 500 milliseconds on and 500 milliseconds off, as per our objective. So let's try simulating. Start simulation. Initializing. As you can see, our LED is blinking. And if you refer to the simulator time, and if you pay attention to it clearly or observantly, you will notice that the LED is blinking 1 time, 0.5 seconds on and 0.5 seconds off indefinitely. This will go on forever or indefinitely until we stop the simulation. So that is all for our program 1A. So let us proceed with our circuit 2. As you can see, for this circuit 2, we have 3 resistor and 3 LEDs connected to pin N plus 1, and pin N plus 2. And all the resistors value is 220 ohms. And our objective for this circuit 2 or program 1B is to write a program to the 3 LEDs shown in the circuit 2 in sequence. Specifically, turn on LED N for 1 second with the others off, turn on LED N plus 1 for 1 second with the others off, turn on LED N plus 2 for 1 second with the others off. Repeat this exactly 10 times, which is 30 seconds in total, and draw the schematic using whatever software that you want to use, and in my case, I will be using Tinkercad again. So let's proceed to our Tinkercad. So as you can see, we've already placed the components again, the Arduino Uno board, the breadboard, the LEDs, and the resistors. So let's take a look at our program code. So we have the variable declarations. We have the int orange 8, declares the integer variable orange and initializes it with the value 8, which represents the pin number to which the orange LED is connected, which is this one. And it is connected to pin 8. We have the int blue, for the green, and pin 9. So, yeah, it's correct. And we also have the int red for the LED red, and it is connected to the pin number 10. So we have the void setup, which as mentioned before, a function that runs once when the Arduino is powered on or reset. It is used for initializing variables, pin modes, etc. And in our case, we have 3 pin modes because we have 3 LEDs: the pin mode orange, the pin mode blue, the pin mode red, and all is set up as output. So this essentially configures the pins specified by the orange, blue, and red as output pins, indicating that these pins will be used to send signals to control external devices, which is in our case the LEDs. And we also have the loop function, which is the void loop. This function runs repeatedly after the setup function has completed. It contains our main code. So we also have the loop function. This function runs repeatedly after the setup function has completed. It contains our main code logic, which in this case we're using for loop. So let's break down what this for loop does. So we have the for, which is the keyword that signifies the beginning of a loop statement. It indicates that a loop is about to begin. And we have the int I is equal to 1, wherein I is less than or equal to 10, I++. So this int I is basically an initialization. This section initializes a loop control variable I and sets its initial value to 1. So the loop control variable is often used to keep track of the loop's progress. And we have the condition I is less than or equal to 10. This section specifies the condition that must be true for the loop to continue iterating. In this case, the loop will continue as long as the value of I is less than or equal to 10. And we have the increment I++, which specifies how the loop control variable I should be updated after each iteration of the loop, which is I++, is a shorthand for the incrementing I by 1 after each iteration, as long as it satisfies the condition. And we also have the digital write for red, orange, and blue. Low is for low voltage, which turning off the red LED. High for high voltage, turning the orange LED, and a delay of 1000 milliseconds or 1 second delay. We have the digital write, orange low voltage for orange, turning it off, and high voltage for blue, turning it on, and another delay of 1000 milliseconds or 1 second delay. And another for blue low voltage, turning it off, and red high voltage, turning it on, and a delay of 1000 seconds or 1000 milliseconds rather, or 1 second. And after the loop, we have the digital write red low, which turns off the red LED. And we have the exit, which ends the program. So if you remember before, our task or our objective for the program is to turn LED N for 1 second with the others off, LED N plus 1 for 1 second with the others off, and LED N plus 1 for 1 second with the others off. And we will repeat this exactly 10 times, which is 30 seconds total. So let's proceed with our simulation. But before that, let's try fixing first the color of the LED so we won't get it mixed up. For this one, we're using blue. And for this one, we're using orange. Okay, now, so now let's start simulation to see if we're accomplishing or if we're satisfying the conditions or the task. As you can see, the moment that the power is turned on, the LED orange turns on, and after 1 second delay, the LED orange off and then the blue turns on, and then another 1 second, the LED red turns on and the blue off, and then the cycle repeats. We'll be doing this for 30 seconds in total, which is exactly 10 times. So we've reached 30 seconds. And does it satisfy? So did we satisfy the condition or our objective for program 1B? Yes, we've turned on the LED orange for 1 second with the others off. And after that, turn on the blue LED and the others turns off for 1 second, and then turning red on while the others are off for 1 second. So that's all for our program 1B. So let's proceed with our program 1C. For program 1C, our objective is this. We need to write a program that uses a function, blink, km, to make an LED on pin K exactly m times, 0.5 second on and 0.5 second off. For instance, the command blink 57 should make an LED on pin 5 blink 7 times. And the program should call blink 3 times from setup to do the following. First is to make the LED on pin N blink 4 times. Then make the LED on pin N plus 1 blink 6 times. Then make the LED on pin N plus 2 blink 3 times. And for our last is to draw the schematic using Tinkercad or fitting software or whatever software that you want. And in our case, we'll be using Tinkercad. So let's proceed to our Tinkercad. So as you can see, we've already placed again the components. We have the Arduino Uno board, the breadboard, as well as the LEDs. We have 3 LED and 3 resistors. And as per the objectives, we need to blink LED on pin N. In this case, we will be pertaining to pin 8, LED yellow 4 times, and then we have the LED green, which is on pin 9 to blink 6 times, and the LED red, which is on pin 10 to blink 3 times. So let's take a look at our simulation code. Okay, so this is our simulation code. We have the variable declarations. Int yellow is on pin 8, int green on pin 9, and int red on pin 10, as I've mentioned before. And we have the void setup, which is a function that runs once when the Arduino is powered on or reset, which is, I've mentioned it earlier as well, for initializing variables, pin modes, etc. And in this case, we have the pin mode, 3 pin modes for the 3 LEDs. We have the pin mode yellow, output, pin 8, the pin mode green for output, pin 9, and pin mode red for output, pin 10. And we have the blink for yellow 4 times, blink for green LED 6 times, and blink for red LED 3 times. So we have the loop function, the void loop, which runs repeatedly after the setup function is completed. So in this case, this is empty. Why? Because there's no need for continuous operations in this loop. We need to satisfy the conditions or the task, the objectives as it is. And in this case, it is specified for the yellow as blink 4 times, the green 6 times, and the red 3 times. And instead of loop, we're using the void blink. So for void blink, we have the initialize k and initialize m. This contains the program for the function belief. This is a custom function named blink that takes two parameters, the k, which represent the pin number, and the m, which specifies how many times the LED should blink. So inside this blink function, we have the for loop, which iterates m times which is the how many times the LED should blink, m times. We have the digital write, k, high, which sets the specified pin k to a high voltage level, turning the LED on, with a delay of 500, which pauses the program execution for 500 milliseconds or 5.5 seconds. And another digital write, k, low, for turning the voltage level off, turning the LED off, and a delay of 500, which pauses the program execution for another 500 milliseconds, creating a blink cycle of 1 second, 0.5 here, and 0.5 here. So let's start the simulation to see if we're really satisfying the condition. So the yellow LED turns on, and it is blinking for 1, this is second time, the third time, and then for the fourth time. Now the green should blink, and there you go. Now this one should blink 6 times as per our code and our objective. Second time, and as you can see, we have the delay 0.5 and 0.5 on and off. The fourth time, the fifth time, and the sixth time. And as you can see, the green LED blinked for 6 times. And now for the red, we have 1, 2, and 3. And there you go. We have 3 times. We satisfied the condition. And as you can see, the loop stops because, as we mentioned before, we're not using the void loop, which will run the function repeatedly. Instead, we're using the blink function, which will satisfy this for loop and will end after satisfying all the conditions or the codes inside of it. So that is all for our program 1C. So now we will do the program 2, which is turning on and off an LED. So these are our objectives. We need to connect a red LED and 220 ohms resistor, which has a banding of red brown, to digital pin N, where N is your team number plus 2. Write a program to turn the LED on and off forever. So we have a hint here. And then the LED should be on for 0.75 seconds and off for 0.75 seconds. And we need to draw the schematic again using any software that you want. So let's proceed to our Tinkercad. As you can see, we've already placed the components. We have the Arduino Uno board, the breadboard, as well as the red LED and the 220 ohms resistor. So let's take a look at our code that will satisfy the conditions. Okay, so we have the variable declaration int LED10, which is on pin 10, the red LED on pin 10. We also have the setup function, the void setup. We have the pin mode LED output, which means that the pin 10 is our output pin. And we also have the loop function, which is a function that runs repeatedly after the setup function is completed. This contains our main code logic, and inside our loop we have the digital write LED high, turning the voltage high, turning the LED on. And we have a delay of 750 milliseconds, which is 0.75 seconds. And another digital write LED for low, turning the voltage low and turning the LED off. And another delay of 750 milliseconds or 0.75 seconds. So let's start the simulation to verify if we are accomplishing the task or objective correctly. the LED should be turned on for 0.75 seconds and off for 0.75 seconds. So the LED will be on for 0.75 seconds. Let's refer to the simulator time. 0.75 it turned off, and 0.75 it turns on again. So we're satisfying the condition. That is all for our program 2, turning on and off an LED.
Here's the continuation of the explanation of the source codes of programs 3, 4, and 5. Without further ado, let's proceed to program 3. Make 2 LEDs blink back and forth, alternating. Let's proceed to our source code right here. Global variables. Int red equals 10 and int green equals 9. These are global variables. These variables store the pins to which the red and green LEDs are connected. Setup function. This function is called once when the Arduino board starts up. It sets the mode of the pins connected to the red and green LEDs as output. This means these pins will be used to send out a signal. Loop function. This function is called repeatedly in a loop. It first turns the red LED on and the green LED off. It then waits for 750 milliseconds. After the delay, it turns the red LED off and the green LED on. It again waits for 750 milliseconds. This cycle repeats indefinitely, causing the red and green LEDs to blink alternately with a delay of 750 milliseconds between the state changes. Here's a quick simulation of the program. Let's proceed to program 4, traffic light circuit. Let's proceed to our source code right here. Global variables. Int red equals 4, int green equals 2, and int yellow equals 3 are global variables. These variables store the pins to which the red, green, and yellow LEDs are connected. Setup function. This function is called once when the Arduino board starts up. It sets the mode of the pins connected to the red, green, and yellow LEDs as output. This means these pins will be used to send out a signal. Loop function. This function is called repeatedly in a loop. It simulates the behavior of a traffic light. First, it turns the red LED off and the green LED on, simulating the go state for traffic. It then waits for 10 seconds. Next, it turns the green LED off and the yellow LED on, simulating the prepare to stop state for traffic. It then waits for 1 second. Finally, it turns the yellow LED off and the red LED on, simulating the stop state for traffic. It then waits for 8 seconds. This cycle repeats indefinitely, simulating the operation of a traffic light. Here's a quick simulation of the program. Let's proceed to program 5, switch-controlled running light effects. Let's proceed to our source code right here. Global variables, int mode, and bool show menu are global variables. Mode is used to store the state of the input pins, and show menu is a Boolean variable used to control whether the menu should be displayed or not. Setup function. This function is called once when the Arduino board starts up. It sets the mode of the pins. Pins 1 to 8 are set as output for LEDs, and pins 9 to 13 are set as input_pull-up for buttons. The show menu variable is set to true. Loop function. This function is called repeatedly in a loop. If show menu is true, it calls the menu function. Otherwise, it reads the state of the input pins, 9 to 13, and if any of them is low, button pressed, it calls the modals, I function with the pin, as the argument. Menu function. This function prints a menu to the serial monitor for the user to choose a light sequence mode. After displaying the menu, it sets show menu to false. Modals function. This function takes an integer argument k, which is the pin of the button pressed. Depending on the value of k, it calls the blink IIK function with different arguments to create different light sequences. Blink function. This function takes two integer arguments, m and k. It turns on the LED connected to pin m, waits for k milliseconds, then turns off the LED. Here's a quick simulation of the program. For mode 1, for mode 2, for mode 3, for mode 4, and lastly, for mode 5. That's all for the explanation of the source codes of programs.